Okay, so hello, my name is Paul Zalsak. I'll be presenting about quantum computing right now. Uh, Before we start, I would just like to address the elephant in the room, and that is my complex complex topic. I just would like to say that it's my hobby to do this presentation. I like quantum computing and all the quantum stuff about it and quantum physics and such as. So I'll try to keep it as brief as possible. So first, we'll go through the topics that I would like to say. What is quantum computer? We will look through how does it work and how we should address whole topic. We will going through the differences between digital and the quantum. And next, we will look into who is already involved, which corporations and companies are already working on the quantum chips, and the future projection for, let's say, next 20 years, or how the industry will be evolving. So, what is quantum computer? It uses quantum principle of quantum mechanics, quantum physics, quantum entanglement, and superposition. Unlike regular digital computers, it uses, instead of bits, it uses qubits, and in order to work with them properly, we need to set the superposition to have them work started with good resolution for them. They are really more efficient than digital, like in a strong way. You just go through the performance, which will be in the next few 10 decades. And it's directly the interesting thing that these qubits directly affect each other. So in the digital, there's like you have the task of the CPU or the unit, and it'll finish the task and then move it to the next one with another input. But the qubits work the way that they listen to different, like the previous qubit, and listen to what is working on it, what is working on the task, and directly trying to help it. So it's like exponentially more effective. It's like when you have a problem in a team and like all people trying to figure it out in let's say 5 minutes. Maybe it's really easier. So we are going through the digital and the quantum differences here. Digital uses a bits to show value, and the quantum uses qubits to show the value. Next is that the digital bits represent either 0 or 1, yes or no, true or false. But the qubits represent anything between 0 or 1. So you might say that you got some solution, but the solution is from 80% correct. But you cannot say it's 100% right. Like it's just all about its probability. It's processing data one by one, and the quantum processes data simultaneously, as I already said with the qubit stuff. They just continue to work everything and the previous. And digital has linear growth, and quantum has exponential growth, which is will we talk about it in the next slide. Yeah, so who is already involved? There's Amazon. Amazon Web Services is already involved, has some quite good prototypes and in the industry. Next, we got the Intel. It has some good ideas too. I would say it's on a good way, but others are much more proficient in this topic. There's a Microsoft that has some is very ambitious about the quantum computing chips in the future. By 2040, it has some ideas that we'll get into. The Google has some stuff, for like example, the chip called G2. I think it was like 5 years ago. They managed to get a chip with 54 qubits that and quite precise on the solutions that made. And finally, we got APM, which is I think the most advantage of the quantum chip, and because it just got everything and just more progress for these years. So we will go through now the future projection for the computing for the next 2 decades, I would say. The first is that IBM wants to have a computer chip with 100,000 qubit by 2032, which is quite ambitious, because these days they have like 432 qubit microchips that are like already kind of good in the probability. but they're aiming to have by 2044, no 2024, they're aiming for the 1000 qubit microchip. Next thing is that Microsoft predicts that the quantum chips won't be as usable until it got 1 billion qubits, which is very, very ambitious. And I know that this today's society is just going exponentially high, and all the tech progress is doing its own. So maybe it will be like 2040. Then we got the probability, qubit, and preparedness, which are the main three factors that we are using for the quantum chips. I think I know this is kind of like really I'm going through the details, but I'll try to finish as soon as possible. Probability means that the result is not, you can say it's right or no. You can say it's true for like 80%, 70%. But if you got too many qubits, it might be 30% or 20%, which is not much, right? So you gotta get the balance between the few qubits but the highest probability. They're working together, and the repairless, which is you can repair it all those negative probability by the error handling algorithms and stuff. And there's astronomical performance in that, which kind of brings me in the question I would like to ask you. That there was some scientist like 10 years ago that do some simulations about the supercomputers and stuff. And quantum computers, there was some simulation that said that a quantum computer can do some hardest challenge in 3 minutes. And I would like to ask you, how much time would you think that quantum computer for the digital regular computer would it get? Like, how much would it take for the regular supercomputer we have all these days?
2.2 seconds.
Okay. Digital. 3 minutes is for quantum, and how much for the digital one? The supercomputer. Any other tips?
10 years.
10 years, okay. Any other tips? Okay, so it is 10,000 years. It's actually like it's exponentially through the roof. It's like so that'll be kind of all for my presentation. We're going to the summary now, and that is I got 5 points, which is measuring unit is a qubit. That's basic from all the digital stuff. Highest probability is the key. If you got 90% or anything and it's high, you just got the right point of view on that. You got a pretty good quantum chip. The three-factor balance, as I already said, I think this point is about more detailed as I would like to have here. But as we said, it's error handling, probability, and the error and the count of qubits. The growth is exponential. Yeah, that's really the main one. That's I think we will feel it within the next few decades. And the future is bright for these companies and for all this quantum chips industry. So here are my sources. I made all the visuals in the Midjourney in the AI. The logos are from companies' official sites, and here are some references, reference links. Just to be honest, from all this stuff, I just had that in my head. So these links are just what you can get, all this kind of what I have in my head in all those sites, because I just like this topic, and just I read all the magazines through the 5, 6, or 7 years or so. So it's not exactly where I've been inspired. So yeah, thanks for the attention.